Hey guys, Mr. B here again, bringing you another trig limit video, and we're going to increase the difficulty level of this one slightly. So we're starting out with something a little more complicated, and again our ultimate goal is to somehow involve our basic definition of the limit as x approaches 0 of sine kx over x, which is equal to just k, the constant in front of your variable inside the sine function. So again, that's our ultimate goal. The only problem is with this example, we have tan involved. So we're going to have to somehow rewrite this guy such that we have limits that we know. And we also know another one, of course, is that the limit as x approaches 0 of cos x is actually 1. So that's something else we can think about maybe possibly using in this one. But anyway, we'll wait and see. So we do know a formula for tan that we can rewrite in terms of sine and cos, which would be tan x is equal to sine x over cos x. So that's something we learned in 3200, and we can apply here. So, boop. Here we go. So limit as x approaches 0 of sine x all over x plus sine x over cos x. So at this point we have a couple of options. The first option, which I personally don't like, is find a common denominator on the bottom. That would work. If we found a common denominator, it would just be cos x. So we would rewrite it as, the x as cos x times x all over cos x. Find a common denominator, flip and multiply, and then, hopefully something cancels, or maybe we can rearrange it a little bit. Well, I think the best option here is just multiply the top and bottom by cos. That way, we get rid of what's on the bottom here of sine over cos, and that way it's already rewrite. So we sort of flip the common denominator, we skip the common denominator and flip the multiply part and get right to what we ultimately want to get. So again, these techniques, they come with practice. So you might got something like this, do it for the first time, you might not be sure what to do. You might try something, but if you're not sure, you gotta try something. So you might try the common denominator, see how far you get with that. It might be a path that doesn't work for you, but you still have to try something, and that's how you get experience with it, trying these questions and trying your own path with them. Alright, so multiply the top and bottom by cos. So the top I have left, I have sine x times cos x all over x cos x plus sine x. So when I multiply, I got cos times that guy, and then cos times this guy, but the cos is canceled in the second part there. So we end up immediately with something that's a little bit reduced down. So now what we can do is we need to somehow again get it to look like this guy, like I've been saying. Make it look like that guy. Well, ultimately how we do that is we have to divide the top and bottom again by x. So that's a technique that often shows up. So let's divide the top and bottom by x. So limit as x approaches 0, sine x cos x all divided by x, all divided by, so I got cos x, whoa, excuse me, x cos x plus sine x over x. So again, I want to write it like that, guys. So if you look here, I have a sine x over x that I can rearrange here a little bit to make it look a bit neater. So the top part I'm going to rearrange a little bit. So limit as x approaches 0. So I'm going to have sine x over x, and that's on the top, times cos x. And then the bottom, if you look here, if I divide my x into both of these things, well, if I divide it into x and the cos, into that guy, the x's will cancel, so I'll just be left with cos on the bottom. And then if I divide it into the sine, I'm left with sine x over x. So now, if you look at it, I have everything in terms of basically the two limits that I know here, right? So sine x over x, so the limit of sine x over x, where k in our case is 1, it's just 1, so 1. The limit of cos x individually is just 1. And on the bottom, the limit of cos x, this guy right here, is also 1. And then the limit of sine x over x is also 1, where k is 1, so plus 1. So I end up with a limit of 1 over 2. So this one was a little bit more complicated, a little bit more algebra involved. But again, ultimately, your goal is to write it in terms of limits that we know. So hopefully this helps. Again, practice is key. And I'll talk to you guys later and see you in class. Thanks.